Now that you're introduced to what is a nucleus, let's talk about couple of parameters what we have here. See, nucleus consists of two particles which you guys already know. Proton, which is a positively charged particle, and a neutron, which is a neutral particle. Okay, a nucleus consists of these two. Now, whenever we talk about atomic mass, we talk about the mass of the nucleus, because the mass of the electron is negligible when we compare to the mass of the nucleus. Okay, so whenever we talk about atomic mass, it is the mass of the nucleus, and when we talk about atomic number, it is the number of protons present in the nucleus. Okay, so nucleus is pretty much the entire thing about an atom. Alright, now whenever we talk about a nucleus, a very important thing comes into picture, which is the size of the nucleus. Okay, now see, when we take size of a nucleus, what we talk about is the radius. Because see, how do we generally represent a nucleus or an atom? We write it like a sphere, correct? That means what we are talking about is the size of the nucleus is pretty much the same as the radius, because if you know the radius, you can calculate what is the volume. It's a sphere, isn't it? So this is what we are going to consider now, which is the size or radius of the nucleus. Pretty much both of them are one and the same. In the sense, from one you can find out the other. That's why we can take size of the nucleus or radius of the nucleus. Now what we know is, experimentally, we have already figured it out, that the volume of the nucleus is proportional to the atomic mass. Don't you think it's quite obvious? Correct? Because more the atomic mass, more number of protons and neutrons. So obviously the volume has to increase. Correct? So volume of a sphere is what? 4 by 3 pi r cube is proportional to A. Correct? Now 4 by 3 pi is constant, isn't it? So now what we have, r cube is proportional to A, or r is proportional to A by 3. Correct? Now to remove this proportionality, we introduce a constant that becomes r is equal to r naught A to the power of 1 by 3. Now r naught is a constant, isn't it? The value of r naught is approximately around 1.2 Fermi, or 1.2 into 10 to the power of minus 15 meter. This becomes the formula for the radius of this particular nucleus, whatever you can take. More the value of A, more is going to be the radius. Okay, now that you know what is the radius, the next parameter which is very important is nuclear density. See, we all know what is density. Density is the ratio of mass to volume. Correct? Rho is equal to m by v. We already know that. Now here we are talking about the density inside the atom. That is the density of the nucleus. Correct? Now we cannot use a conventional way saying that, okay, this is the mass, this is the volume, do mass by volume. So conventional method is not going to work here. So what we do, we talk about m being the mass of one nucleon. One nucleon in the sense, one proton or one neutron, one nucleon. Okay. Now r is the radius of the nucleus. Now you know that A is the atomic mass. So Ma becomes the total mass of the nucleus. Correct? Or you can say the total mass of all the nucleons. That also makes sense, isn't it? Now total mass we know. Now we have to calculate the volume. Volume is what? 4 by 3 pi r cube. So 4 by 3 pi into r naught A power 1 by 3 whole cube. Now if you do this, you are going to get 4 by 3 pi into r naught cube into A. Now rho is equal to mass by volume. So Ma divided by 4 by 3 pi r naught cube into A. Now A and A gets cancelled. So the 3 goes to numerator. Rho is equal to 3m divided by 4 pi r naught cube. Now here, don't you think everything is constant? M is what? Mass of one nucleon. Either a proton or a neutron, pretty much one and the same mass. So numerator is constant. Denominator, 4 pi r naught is also constant, 1.2 Fermi. So if you apply all these values, we get rho is equal to 2.29 into 10 to the power of 17 kg per meter cube. Okay, so this is what is the density in the nucleus. This is a lot, 10 power 17. Not even take any element, take any star, none of them will have this kind of density except for one star, which is a neutron star. A neutron star has density of this much, whatever we just calculated. Okay, because the neutron star is filled with just neutrons. The name itself suggests neutron stars, correct? So the density of a nucleus is 2.29 into 10 power 17. And density is the same for each and every element or each and every atom. Because it is independent of the mass number, isn't it? So whatever might be the size, the density of the nucleus is going to be the same. And the numerical value is 2.29 into 10 to the power of 17 kg per meter cube. Now that we discussed about parameters regarding the nucleus, as in, the volume, the density and the size and everything, what if we have different types of elements having same number of neutrons? So what I'm talking about is isotopes and all. Okay, so in the next video we'll discuss about these things.